Hello everyone, this is Dr. Manali Datta and welcome to my channel Chemistry with Manali. So in the previous videos we have had an elaborate discussion on the basics of organic chemistry. So today we will be discussing about how to write the structure of alkanes, alkenes and alkynes. So we will take up these three classes of organic compounds and we will see how do we write the structure of those compounds and what are their names, their molecular formula and structural formula. So as we already know that the general formula of alkanes is CnH2n plus 2. So by substituting n equal to 1, 2, 3, 4 etc. we can find out the molecular formula of the alkane and its corresponding structure. So let us begin. So when the number of carbon atom is 1, then what will be the formula? So here if I substitute n equal to 1, the formula will be CH4. If n is equals to 2, the formula will be C2H6. If carbon number is 3, formula will be C3H8. If it is 4, C4H10. 5, so this is how by substituting values of n from 1 to 8 we can derive the molecular formula of the alkanes. And what will be the names of these compounds? So if carbon number is 1, the name is meth and we end it up with N. N comes from this alkane, that is from the parent name. If number of carbon atom is 2, the name will be eth and we end it up with N. If number of carbon is 3, it is propane. If carbon number is 4, butane. 5, pentane. For 6, it is hexane. For 7, it is heptane. For 8, it is octane. For 9 and 10, for 9 it is nonane and for 10 it is decane. Now how to draw the structure? For 1 carbon atom, just put 1 carbon, and since we already know that the valency of carbon is 4, so to make up the valencies we will just put 4 bonds around carbon and put hydrogen atoms around the carbon atoms. Now for ethane there are 2 carbons, so just put 2 carbons and then substitute and then make up its 4 valency by substituting hydrogen atoms. You can again cross check whether the number of carbon atom is 2 or not and the number of hydrogen atom is 6 or not. For propane, simply draw 3 carbon atoms and make up all the valencies of carbon by substituting hydrogens. Similarly for butane, put 4 carbon atoms and then substitute all its valencies by hydrogen atoms. For pentane also 5 carbon atoms and then make up its 4 valencies by hydrogen atoms. So this is how you can draw the structures of the compounds from their molecular formulas. Now let us try to understand how to draw the structures of alkenes. Now we know that the molecular formula of alkenes is CnH2n. Now again by substituting the values of n we can derive the formula of the alkenes and their corresponding structures. But one thing to remember is in alkenes there will be a double bond between the 2 carbon atoms. Now let us see what will be the structures and the formulas. Now for the simplest, alkene starts with carbon number 2 because the reason being we need a double bond between the 2 carbons. So there is no alkene with 1 carbon atom. So we'll start with carbon number 2. If n is equals to 2, then the formula will be C2H4. If n is 3, C3H6. If n is 4, C4H8 and so on. C8H16. Now again similarly for 2 carbon atoms the name will be eth, and we will end it up with the parent name, that is in. For 3 carbon, propene. For 4 carbon it is butene. For 5, pentene. For 6 it is hexene. For 7, heptene. For 8 it is octene. For 9 it is nonene. And for now to draw the structure of ethene, we will simply put 2 carbon atoms, and since it is an alkene, we will put a double bond between the 2 carbon atoms, and then we will make up the 4 valencies of carbon by hydrogen atoms. Now we can check that, we can check from the molecular formula, and also we can assure whether the valencies of carbon atoms is 4 and the valencies of hydrogen is 1. Next for propene, just put 3 carbon atoms and put a double bond between the carbon atoms. So until and unless the position of the double bond is specified, we will always put the double bond between carbon number 1 and 2. Now make up the valencies of all the carbon atoms by substituting with hydrogen. Similarly for butene, put 4 carbon atoms, put a double bond between carbon 1 and 2, and then make up the valencies of all the carbon atoms. Similarly for pentene, put 5 carbon atoms, put a double bond between carbon 1 and 2, and then make up the valencies of all the carbon atoms. Similarly hexene, 6 carbon atoms, and then double bond between the first 2, and then make up the valencies of all the carbon atoms by substituting with hydrogen. So this is how we will draw the structures of alkenes. Now the last one is alkynes, that is the triply bonded organic compounds. The general formula is CnH2n-2. Now let us see how to draw the structure. So here also similarly, since there is a double bond between the carbon, there is a triple bond between the carbon atoms, the simplest alkyne starts with carbon number 2. There is no alkyne with carbon number 1. So if the number of carbon atoms is 2, the formula will be C2H2. If the number of carbon atom is 3, the formula will be C3H4. If the number of carbon atom is 4, the formula will be C4H6. So here also for 2 carbon atom the name will be eth, and then we will end it up with the parent name ine. Ine comes from this alkyne. For 3 carbon it will be propyne. For 4 carbon butyne. For 5 it is pentyne. For 6 hexyne. For 7 it is heptyne, and for 8 it is octyne. Now for drawing the structures of this compound, for ethyne we will again similarly put 2 carbon atoms, and since it is an alkyne we will put a triple bond between the 2 carbon atoms and then make up its valencies. So we can cross check whether both the carbons have 4 valency or not. Now for propyne, that is 3 carbon atom, just put 3 carbon atom and triple bond between carbon number 1 and 2. So for this carbon we do not need any extra hydrogen because it is already tetravalent. All its 4 valencies are already satisfied, and for this carbon atom we need to put only 1 hydrogen atom. Similarly for butyne, put 4 carbons, triple bond between carbon 1 and 2, and then complete all the valencies of carbon. For pentyne, 5 carbon atoms, triple bond between the first 2, and then make up the valencies of all the carbon atoms. So this is how from the molecular formula we can draw the structure of the organic compound. The first thing to keep in mind is, the first step is just put the number of carbon atoms whatever is specified in the molecular formula, and then satisfy the valencies of each atom, that is cross check whether all the valencies, 4 valencies of carbon are satisfied or not. For example, here only 1 hydrogen is required to satisfy the 4 valency of hydrogen. For this carbon, no other hydrogen is required because it has already formed 4 bonds with its with its neighboring carbon atoms. So this is how we draw the structures from the molecular formula in case of alkenes, alkanes and alkynes. So one last topic for today's video will be alkyne group. This is what we will be discussing, alkyl group. So what is an alkyl group? So when a hydrogen atom is removed from an alkane group, this is an alkene, this is a methane. If we remove a hydrogen atom from this alkane group, what will we get? CH3. This CH3 group, which is one hydrogen short of this alkane, is called an alkyl group. So its name will be methyl. For one carbon atom it is meth, as we have already discussed, and this yl comes from the parent group alkyl. Similarly, if I take another alkene, C2H6, this is an ethane. If I remove a hydrogen atom from this ethane, I'll get C2H5. Now this is a ethyl group. Ethyl because it contains 2 carbon atoms, and yl comes from the parent name alkyl. Now why did I put a bond here? Because here the valency of carbon is not satisfied. It has 3 hydrogen atoms, so it requires another group to satisfy its 4th valency. This is the reason I have put a bond here to indicate that some other group may come up here and satisfy the tetravalency of carbon, because hydrogen is already removed, so one site is vacant for a group to come up and bond with this carbon. Here also I have put up a bond here. The reason being, if I try to draw its structure, for 2 carbon atoms I'll put it like this and 5 hydrogen atoms. 5 hydrogen atoms means 2 with this carbon and 3 with this carbon. So for this carbon I can see that the valency is not satisfied. There are 3 valencies, 1, 2 and 3. So this site is vacant. So some other group may come up and bond with this carbon to satisfy its tetravalency. This is the reason I have put a bond here. So this is all about alkyl group. So that's all for this video. So you can just take up various groups of compounds belonging to alkanes, alkenes and alkynes and see how you can draw the structures from their molecular formula. So thank you all. If you found this video informative, please like and share my video and subscribe to my channel. Thank you all.